Hello friends, we are resuming our last discussion. In last lecture we had discussed the various sources of the electrical energy and then the sources conversion. We also discussed the utilization, or you can say that the application of source conversion by discussing one example. Today we are going to discuss the basic laws of the electrical engineering. Now, as you already know that we are having several laws which are known as the fundamental laws of the electrical engineering. Particularly, you can say that we are having the three basic laws of the electrical engineering. The first one, that is known as the Ohm's law. The Ohm's law states that the current flowing through electrical circuit is directly proportional to the potential difference across the circuit and inversely proportional to the resistance of the circuit, provided the temperature remains constant. This is very important. Here we are applying the Ohm's law by having the assumption that the temperature remains constant. If the temperature and all climatic situation assuming constant, then it states that current I is proportional to voltage V, where V, that is the potential difference across the element, and I, that is inversely proportional to the resistance R. Definitely we can extend this Ohm's law to AC circuit also, but right now we are confining our discussion with the DC circuit only. It means that if we know any two of these three values, that are the current, voltage and resistance, then we can find the third one. So we can conclude like that: if the resistance is constant, that means it does not change, then the voltage increases as the current increases because I is proportional to V. Similarly, voltage decreases as the current decreases because I is proportional to V, or we can also say that the V is proportional to current I. Hence, as voltage and current, in both these cases, if one quantity is going to increase, assuming that the resistance of the circuit is constant, then you can say that the remaining quantity, that is the current or voltage, is also going to increase or decrease. Similarly, suppose we are assuming that if the circuit voltage is not changed, that means if it remains constant, then the resistance will increase if the current decreases, because as we discussed in the previous slide that the resistance, that is inversely proportional to the current, or you can say that the current, that is inversely proportional to the resistance. So considering this, the value of resistance will increase if the current decreases, and vice versa. That means the value of resistance will decrease if your current is going to increase. So now here we can portray the Ohm's law by using this triangle. In some literature, this triangle is also considered as the Ohm's triangle, or you can say that it is the magic triangle. Here we are having the three quantity that the Ohm's law relates, that is the voltage, current and resistance. Voltage can be represented by either E or V, while the current is represented by I and resistance is represented by R. Assuming that suppose we are representing the voltage by the capital V, then V is equal to I into R. That is the derivation we can get from the basic Ohm's law. So now here what is voltage? As in previous lecture it has already been discussed that the voltage is the push or pressure behind current flow through a circuit and is measured in volts. Here in figure, the analogy between the voltage and flow is given. As we already know that the flow of water coming out of the pipe depends on the pressure. Similarly, the current that you can say that flowing through the circuit depends on the pressure, and that pressure is known as the voltage. The unit of voltage is volts. We are measuring the voltage in volts. Similarly, what is current? So current refers to the quantity per volume of electrical flow that is measured in ampere. Again here we are having the analogy. From figure we can say that the measured quantity, that is the flow of the water. So here in our case, that is in electrical engineering, the current that is refers to the quantity per volume of the electrical flow. Now generally the current is nothing but, as you already know, that due to the charge transfer we are saying that the current is flowing. So here whatever is the quantity that is flowing, in case of the electrical engineering, that will be considered as the charge. So you already know that we are having the relation that the I is equal to dq by dt, which is followed by this equation. Similarly, the third parameter, that Ohm's law, is relating with the first two parameters, that are the voltages and current is resistance. So the resistance to the flow of current, that is measured in the ohm. So as we already experienced that if at the outlet of the pipe, if we put our finger or say thumb, then the flow will find some resistance. Here the water will find some resistance. Similarly, the current is also facing some hurdle or resistance when flowing through the circuit. That is known as the resistance of the circuit. So the resistance of the circuit is measured in ohm, because we are discussing about the Ohm's law, and behind his name it is measured in ohm, represented by the nomenclature or the symbol which is shown in the slide. Now first of all, how to use the Ohm's law? If you would like to use the Ohm's law, then it is very simple, as we have to simply remember this triangle, which is also known as the Ohm's triangle. Now in this triangle three quantities are given. So whichever quantity we would like to find, we have to cross that quantity. So that will give you the relation to find that quantity with the another two. Now we are having the equation that I is proportional to V upon R. That is basically known as the Ohm's law. But here we, from the same equation, we can say that the V is equal to I into R, then R is equal to V upon I, and as we already have one equation, that is equal to I is equal to V upon R. So here V upon I into R will form your magic triangle. So suppose if I want to find the resistance, I have to cross the resistance. So the remaining two quantities, that will give me the ratio of voltage to current, and it will give me the value of resistance. Similarly, suppose if I want to find the voltage, I have to cross over the voltage, and if I forget the voltage from this triangle, then I into R will give me the value of the voltage. And the same thing we can repeat to find the current also. Now here, if you want to find the current, you simply put cross over the current. So the remaining two quantity are the ratio V upon R. Hence, using this triangle, one can find the relationship of voltage, current and resistance, and if two quantities out of these three are known, then the third unknown quantity can also be found. Here, suppose the battery voltage given is equal to 12 volt and the resistance of the circuit is 2 ohm, then what will be the current that will flow through the circuit? This is a problem. So now here the battery voltage, that is E, is equal to given, so E is equal to 12 volt. Resistance, that is R, is given, R is equal to 2 ohm, and current is to be found. So you simply cross over the I, so it will give you the ratio E upon R. Substituting the value E upon R, here we are getting the 12 volt divided by 2 ohm, that is equal to 6 ampere. So 6 ampere will be the result. So now, considering this, we can calculate any of the parameter of the Ohm's law. Now, here important thing about the Ohm's law that we have to remember is, here we are working based on one assumption, and that assumption is that here the temperature remain constant. Here I would like to point out few things about this assumption. As we already know that in practice generally the temperature is not constant, because the temperature depends upon the heat loss that might incur in the circuit, as well as you can say that temperature depends on the ambient temperature of the atmosphere. So due to this, if suppose the temperature is changed, then in previous lectures when you studied the circuit elements, you found that the resistance R is temperature dependent quantity. What it means, if your temperature is going to change, then the circuit resistance is also going to change. If you recall, then you know that the RT is equal to R0 1 plus alpha 0 T. Using this equation, we can find the value of resistance at any given temperature. If temperature change, the resistance change, and if the resistance is changing with temperature, then we cannot apply the Ohm's law. So this is the limitation of Ohm's law that you can say. Here, under the assumption that the temperature remain constant, we are applying the Ohm's law. Second thing, you must know that the Ohm's law is applicable both to AC circuit and DC circuit, but particularly in this chapter, we are confining our discussion for the DC circuit only. Now, the next two laws that we are going to discuss are known as the KIRCHOFF'S law. Ohm's law, that is the law or the name given in memory of its inventor, that is the Ohm, who was the scientist. Similarly, the KIRCHOFF'S law are also given the name behind the scientist. Now, before applying the KIRCHOFF'S law, we must know some basic terminology that we are using for the circuit. We can say that it is known as the circuit definition. The first point is node. Any point where two or more circuit elements are connected together is known as node. So here, see, what we are doing is, if suppose we are finding some point in the circuit at where two or more elements may be the voltage source, it may be the resistance, it may be the inductance, or it may be the capacitance. Okay, so if any of two elements are connecting at a particular point, then we can say that that particular point is known as the node of a circuit. So we are going to discuss this node in detail in successive slides. Now, whatever the wires that we are using to connect the elements are having the negligible resistance, and hence the resistance of the wire should be ignored. So that is also the thing that we are going to discuss, because as you already know that we are having certain elements in the circuit, but to connect these elements we require the wire. Now the wire itself may have some resistance, but generally we are neglecting this resistance because the wire is made of a conducting material. It may be the copper or aluminum. So as we already know that the resistance of this conducting material is very low, so we are neglecting this resistance. Now whenever we are defining the node, we can measure the voltage at that particular node. The voltage at a particular node means here you can say that on the node, if we connect the voltmeter and the second terminal of voltmeter is connected with the ground, it will show the potential difference between that particular node and the ground, and this potential difference is known as the voltage of that node. So each node has one voltage. Now the second element of the circuit, or the second definition about the circuit, that is known as the branch. Branch is a circuit element between two nodes. That means if our two nodes are connected by some element, then some circuit element definitely, maybe the resistance, inductance, capacitance, or say the source, maybe the voltage source or current source. At that time it is known as a branch. That means you can say that branch is connecting two elements. Okay, and the third one, that is known as the loop, a collection of branches that form a closed path returning to the same node without going through any other branch. Any other node or branch is known as the loop. That means in short, in loop, no node or no branch should get repeated. So if we are starting our journey from one node, we are traveling through several branches without repeating any node or branches and coming back to that node from where we started our journey, then it is known as loop. We are going to discuss this. Okay, now suppose this is the circuit given, and here suppose we want to identify the number of nodes, number of branches, and number of loops. Now here in this circuit you can say that this is our voltage source, that is the constant source that we already discussed in the last lecture. Again I would like to repeat that it is constant voltage source or constant time invariant voltage source because it is DC voltage source. We are also having one current source which is also constant in nature, and as the direction is given, we can say that the current source is also time invariant in nature. The circuit consists three passive elements: resistance R1, R2, and R3. As discussed in the previous lectures, you identified that the network element or circuit elements are classified as passive element and active element. So the resistance, inductance, and capacitance are known as the passive element of the circuit, and here you can say that we are having the three passive elements R1, R2, and R3 in the circuit. So if you find that the total number of elements in the circuit are 3 resistors plus 1 voltage source plus 1 current source, that is equal to 5. Now we are trying to identify the number of nodes, number of branches and number of loops. Again recall the definition of the nodes. The node is a junction point or point in a circuit where more than one branches, that means two or more branches are connected. Here you can say that the first element here, that is the voltage source. The second element which is connected with the same point, that is known as the resistance R1. So this point will be identified as the node of the circuit. Similarly, here you can say that the R1 and R2 are connected at this point, so this point will also be considered as the node. Similarly, at this point you can say that we are having R3, R2 and R1. Definitely here also you can say that the R1, R2, R3 and IS all are connected. How? That I am going to explain. Okay. So now here the nodes are identified. See, the first node of the circuit is here the R1 and Vs both are connected. That means two or more elements of circuit are connected. So it is given as the, or it is identified as the node. The second one, at this point. Someone may think that at this point only two circuit elements are connected, R1 and R2. But it is not true. Why? Because you can say that the R3 is connected with this line and this line is nothing but, as we discussed, that the line is some connection or some connecting wire. So if we neglect the resistance of that connecting wire, then we can consider this point and this point both same. So what it means now, earlier as we thought of that, the R1 and R2 are connected at this point. Now you can say that the R1, R2 and R3, all these three resistances are connected at this point. Again, we can correct our answer because the IS is also connected with the same point. Okay, so we are considering this point and this point as the same point because in between no other element is connected. So all points in a circuit in between, if no other circuit element is connected, it will be considered as the common point. So as this is our first node, you can say that this is your second node. Remember, it is not like that this is your second node, this is your third node and this is your fourth node. Okay, but it is like that as between these 2 points, this point and this point, no element is connected. That means both these points are common. Similarly, between these 2 points, no element is connected. That's why these 2 points are also common. So finally all this forms a common point, or you can say that it will form a node. Here you must understand this and there should not be any mistake in identifying the node. Similarly, here you can say that the negative of the source, the second terminal of resistance R2, second terminal of resistance R3, and you can say that the second terminal of current source all are connected at the bottom point, and so we can identify this all as the common point, and that is also your node. So now we are having the first node, second node and third node. Second thing that I would like to tell you, that definitely you will learn it later on, that we can consider both these points same because the potential of both these points same. This is also important because when defining the node, we said that each node has one potential. That means if I am measuring the voltage at this point with reference to ground or say the negative of the battery, then whatever the value I found, the same value I will have if I found or I measure the voltage at this point and the common reference that we identified. So if the potential of different points in a circuit is same, then that particular points, if connected, are considered as the common point or common node. So in this circuit we are having 1 node, 2 node and 3 node. I think that we have discussed enough about the node. Now there should not be any confusion about the node. Okay, so now we are going to find the branches in a circuit. So branches in a circuit, that means branches is the number of elements in a circuit. Now here you identified that one voltage source, second one that is the current source, third one that is the resistance R1, fourth one that is the resistance R2, and fifth one that is the resistance R3. So here you can say that these 5 elements are given in the circuit, and that's why the number of branches are 5. Again remember that the line which is drawn to link or to connect the 2 elements of the circuit will not be considered as the branch. So the total number of branch will be counted like this. So in this circuit you can say that we are having, say, the total number of 5 branches. Here one important thing that I would like to tell you is that the current source is given, and across the current source the voltage is given, that is the plus minus VO. Now that is known as the terminal voltage that will appear across the current source. Generally, as per our standard nomenclature, we are considering the upward direction of the arrow as the positive polarity and the remaining terminal of the current source as the negative polarity. So that is the thing that you have to remember. Okay, so now the third circuit definition that we had, that is the loops. Now we are identifying the loops. Suppose if I start my journey from the point number A and traveling through various branches of the circuit and coming back to point A without repeating any branch, then it is known as the loop. So now it is possible that in this circuit different loops are there. If you see that, suppose I start my journey, I am traveling through the point A, then through resistance R1, then through resistance R2, then through the negative of voltage source to again back to the point A. So basically what happens, the loop is nothing but it is the closed path. It is the closed path from where the current will flow through the circuit. Okay, so we are defining the loops, and later on in successive chapters we shall also define the loop currents. So basically loop is nothing but it is the closed path. As we already know that current can flow only if there is a closed circuit. So loop is nothing but it is the closed path. Similarly, I am going to identify the second loop. The second loop can be identified like this. Suppose again I am starting my journey, say from the point A, I am going through the resistance R1, I am going through the resistance R3, coming back to the voltage source and then back to the point A. So this will form my second loop. And similarly, you can say that my third loop will be again starting to travel from point A, resistance R1, then through the current source, and then again to the voltage source. So this is my third loop. So this is how we are defining the loop. See, the loop is a closed path. That is the first thing. Second thing, in loop, no branch should be repeated. In loop, no node should be repeated. My traveling point and destination point both are the same. That means the point from where I start my traveling, I will be back there. Then only the path will be closed and it will be known as the loop. So I think here we have considered three important circuit terminology. The first one, that is known as the node. In this circuit you can say that A, B and C are given the name of the node. Okay, then the branch. So R1, R2, R3, IS and VS. These 5 elements are given in a circuit and they will form the branch. And loops, the number of closed paths in a circuit. So we are saying that starting from the voltage source through R1, R2, first loop, starting from the voltage source to R1, R3, second loop, and again starting from the voltage source to R1, IS, the third loop. Now after having this much knowledge, we are going to discuss the KIRCHOFF'S law. So Kirchhoff is the name of scientist who has given two very important law in electrical engineering. The first law, that is known as the voltage law, and second one, that is known as the current law. So the Kirchhoff's voltage law is known as the KVL also. The Kirchhoff's voltage law is the algebraic summation of voltages around each loop is 0. We are going to elaborate this. Okay. So if I am traveling across the loop, then the voltages across circuit elements, if I algebraically add it, then it will be equal to the 0. Now, as we are following the path of the loop, that means we are beginning our journey with the node. So from that node we are going to add the voltages across each branch in the loop, and suppose we are saying that the branch voltages are given the positive sign and we are subtracting the voltages if say we are giving the negative sign to that particular branches. Now the sign convention is like that. Say if we are giving say the positive sign to the voltage drop, then we have to consider the negative sign if the voltage is raised. That means if I am moving from one node to another node and the voltage is dropping, voltage drops, then you can say that our sign is positive. But if I am say traveling from some another node to some other node and the voltage is raised, then we can say that our sign considered is negative. Now as in case of the node definition, I told you that each node has voltage. That means suppose if I am considering the node A in previous case and say here the node B is there, if I am traveling from here to here and I found that the voltage of node A is more than voltage of node B, that means voltage drop take place across the resistance R1. according to my standard convention, I am considering this voltage drop positive. But now say if I am moving from the branch C to the node C to the node A, then in between node C and A, I am having one voltage source. As you can observe that the C is connected with the negative of the voltage source, A is connected with the positive of the voltage source. Obviously, the potential or the voltage of node A is more than the potential or voltage of node C, because A is connected with positive and C is connected with negative polarity of the voltage source Vs. If it is that, then if I am moving from C to A, voltage rise will be there. If I am considering the voltage drop positive, then I must consider voltage rise negative. One can think in the reverse direction also, but you have to decide which convention you would like to follow, and it should remain same for the analysis of a given circuit. It should not like that once we are considering voltage drop positive and in another case we are considering the voltage rise positive, it will give us a false result or incorrect result. So now, using this sign convention, we are going to discuss the KVL. So the algebraic summation of voltage drops that we are going to consider as the positive plus algebraic summation of voltage rise is equal to 0. Here, if algebraic we are considering these are the positive quantity, then it will definitely considered as the negative quantity. That's why here it is the negative. Or you can say that the number of voltage drops should be equal to number of voltage rise. So this is the KVL. Now suppose if I am applying the KVL for this circuit for the first loop, then I can say that the I1 R1 voltage drop, if current I1 is passing through the resistance R1 and let current I2 is passing through the resistance R2 and Vs is the source, so if I am moving from A to B, then according to Ohm's law, V is equal to I into R, and hence the voltage drop that taken place across this resistance R1 is equal to I1 into R1. So this I1 R1 I am considering as the positive. Okay, so first of all I am assigning the direction of the current. Let the current is flowing from the positive to negative, so the direction of flow of current will be like this from the source to the branch. Okay, then I am saying that here according to Ohm's law the I1 R1 drop is there and we are considering it as the positive. So the voltage drop, this is I1 R1, this terminal will be positive, this terminal will be negative. The same situation will happen at the I2 R2 also. So the point where current is coming will be considered here as the positive. The point from where current is leaving will be considered as the negative. So this is my I1 R1, positive to negative, that is voltage drop, positive to negative, that is voltage drop. I am considering the voltage drop as the positive and the loop is there, so I am traveling from A to I1 R1 plus I2 R2. Now the negative to positive will be considered as the voltage rise, and as it is considered as the voltage rise, you can say that the Vs should be considered as negative. So you can say that the starting at node A, so plus I1 R1, we are writing the Kirchhoff's voltage law for these three branches, this branch and this branch. In general, we are writing Kirchhoff's voltage law to all those branches which are in path of a loop. If I am considering the first loop, then this branch, that is the R1, R2 and Vs will come into the picture. So again from node A it is the plus I1 R1, then here it will be considered as the voltage drop, positive to negative, that is the voltage drop. So that is according to our convention plus I2 R2, and then this one, that is the third one, that is negative to positive. We are saying that it is equal to voltage rise, and we are considering voltage rise negative. That's why the minus Vs is equal to 0. Because Kirchhoff's voltage law states that algebraic summation of all the voltages around any closed path should be equal to 0. Here we are having the 3 voltages, so algebraic summation of these 3 voltages will be equal to 0. So here we have got 2 positive voltage and 1 negative voltage. Okay, now here we can say that the second law of the Kirchhoff, that is known as the Kirchhoff's current law. Now in case of the Kirchhoff's current law, what we are discussing, see the Kirchhoff's voltage law, that is we are traveling through the loop. In case of the Kirchhoff's current law, we are writing the Kirchhoff's current law at a particular node. Now the algebraic sum of currents entering a node is equal to 0. Now see, the term algebraic sum is there. Okay, so if I am saying that at some particular node some current is incoming current, then it is considered as the positive, and at that particular point if the current is leaving the node, then it will be considered as the negative, because the Farada's use is the algebraic sum. Now here you can say that if we are adding the each branch current entering the node and subtracting each branch current that is leaving the node, that means its algebraic summation will be equal to 0. Again, it is Kirchhoff's current law. So we are writing the Kirchhoff's current law for the current. Okay. So now here you can say that the sigma currents in that means incoming to the node, minus sigma current out means current going out of the node, should be equal to the 0. Or you can say that current entering the node should be equal to the current going out of the node. That is known as the Kirchhoff's current law. Now suppose here we have identified the 3 nodes as we already discussed, A, B and C. Now at particularly node B we are having the outgoing current. Say this is my I2 current, this is my I3 current, and 2 incoming currents, that is the current I1 is coming to the node B and current IS is also entering to the node B. Again I would like to repeat that all this portion displayed inside this green circle is considered as the node B. Okay. So if I am saying that the incoming current is considered as positive and outgoing current considered as negative, then I can write the Kirchhoff's current law like this. I1, that is incoming to the node B, we are considering it positive, so that is the positive I1. I2, that is leaving the node B, it is going out of the node B, so it will be considered as the negative. That's why minus I2. I3 is also leaving, that means it will be considered as the I3 negative, and the IS, that is incoming current to the node B, so IS will be considered as the positive. So here you can say that I1 plus IS is equal to I2 plus I3. I1 and IS both are current entering the node, I2 and I3 both are currents leaving the node. So this is the application of the Kirchhoff's current law. So now suppose we are using these two Kirchhoff's law, that is known as the Kirchhoff's voltage law, and Kirchhoff's current law, that is the KVL and KCL, for the circuit analysis. Suppose one circuit is given and I want to find the voltage across these two terminals, which is known as the VAB. Okay. Now, first of all, I can say that if I am applying the KVL for this loop, then I can say that the minus I1 into 8 plus I2 into 4 is equal to 0. Okay, so here negative to positive, that is the voltage rise. Voltage rise is considered as minus, so minus I1 into 8. Here the positive to negative, if I am traveling, then it will be considered as the voltage drop, that is the I2 into 4 is equal to 0. That is my one equation. Second equation is, from this equation I will have the I2 is equal to 2I1. It is simply the mathematical step. The third one is, if I am applying the KCL at node A, then 10, that is the incoming current, I1 and I2 are the outgoing current. So I can say that the incoming current should be equal to the outgoing current. That's why 10 is equal to I1 plus I2. Substituting I2 is equal to 2I1 in this equation, you can say that I am having the I1 is equal to 3.33 ampere and I2 is equal to 6.67 ampere. Now the VAB, that is the voltage across these two terminals, that is equal to the voltage across this 4 ohm resistance. Voltage across the 4 ohm resistance is equal to current I2 multiplied by the 4 ohm resistance. According to Ohm's law, V is equal to I into R. Okay, so the voltage VAB is equal to I2, which is equal to 6.67 multiplied by 4 will give you the 26.33 volts. So that is all how we are applying the Kirchhoff's voltage law and Kirchhoff's current law to analyze the circuit. Now this is the website on which different animations are available through which you can practice these circuit concepts, and these are freely available. Okay, so now today we discuss the basic laws of the electrical engineering, that are the Ohm's law and Kirchhoff's law, that are the Kirchhoff's voltage law and Kirchhoff's current law. Here I conclude my this session, and also I think the topic, that are the sources, energy sources, type of sources, source conversion, and the basic laws of the chapter number 1 of the subject EEE, that are covered. Thank you very much.